அனைவருக்கும் வணக்கம். யாவரும் கேரிய திருமலர் சங்கம் பெருமையுடன் நடத்தக்கூடிய நிற்க அதற்கு தக மாணவர்களே ஆசிரியர்களாய் வாரம் 14 நீங்கள் அறிந்ததை மற்றவர்க்கும் கற்பித்தால் நீங்களும் ஆசானே. இந்த வார நிகழ்ச்சியில நம்மளோட கலந்துருக்காங்க ஃபைஹா அஞ்சுங்கிறவங்க. வாரந்தோறும் சனிக்கிழமை மாலை 6 மணிக்கு YK டேலண்ட்ஸ் நேரலையில் காண தவறாதீர்கள். ஆல் தி பெஸ்ட் மா. Faiha Anjum.
Okay, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you.
So first, let me share my screen.
Yeah.
So firstly, I would like to thank YK Talents for providing me this wonderful opportunity and my guidance, Dr. Charumati ma'am. For guiding me in the right path, and I also would like to thank all the viewers for listening this series. So before moving to the topic, I would like to ask you a few questions. Have you ever wondered why the hair is so thin and what is the measurement of hair? Obviously, many students will say no and few students will say yes. So this comes under nano, and nano is nothing but a billion part. So altogether, nanochemistry is a combination of chemistry and nanoscience, which associate with the synthesis of a building block, which depends upon the size, surface, shapes, and directive properties. So in these lectures, we are going to see the synthesis of nanomaterials by physical and chemical method. Okay, and also we are going to see and listen about the nucleations and the growth and how to synthesize metal nanoparticles and nanorods. Okay, so first we are going to see physical method. Under physical method, there are many types, but in this lecture series, we are going to focus mainly on mechanical milling and laser ablations. So let us see what is mechanical milling. Mechanical milling is nothing but it is a top-down process, which means we are making from bulk nanoparticles and nanomaterials, and these particles will form a mechanical devices. In generally, we are referred it is as a milling. So here we are going to use metallic ball so that we are going to break a bulk materials into nano size particle. Okay, so let us see the principle of milling. So here the fundamental principle of size reduction in the mechanical device is the energy impact to the sample during the impact between the milling media. So this module represents the movement of collisions. Here you can see the two half balls. You can see, right, the two half balls. So I'll use the cursor here. So this series or a trap between the two colloidal balls. Within that, the space is occupied by the mass of powder particles. So this circle will tell you how a mechanical milling works. So here the mechanical drum is to rotate a magnetic or a metallic balls will be getting fall on the powder, and it is going to break a macro size powder into nano size powder. So this is a micro size powder, and here a small size powder is a nano size powder. Okay, so this is a mechanical milling or a ball milling equipment. Okay, so we can call it as a ball milling because due to we are using magnetic balls, and this is an microscope pictures. For seeing this nanoparticles, you need to have an electronic microscope. So this is an electronic microscope. So this are the scannings of electron microscope pictures you can see here. So the orange color figure is an electronic microscope. So the side is A. The figure is after 3 hours of milling, and figure B is after 9 hours of milling, and figure C is after 15 hours of milling, and figure D is after 20 hours of milling. So we can see here with respect to time, the particles of the size is going down and down. So here it is somewhat dark, and it has become somewhat like scales in color. Uh, and whenever you take a picture, you have to insert a scale bar. So here the scale bar is. So the scale bar is very important here, which will be useful in calculating the size of the particles. Okay. So let us see the next method, that is laser ablation method. Okay. Here you will be using the laser light to vaporize your materials and nanoparticles by laser ablations, which involves in the generations of nanoparticles by a laser ablations of a solid targets. So we can get nanoparticles in a gaseous state, or it can be obtained from the liquid environments. Also, it can be depend upon the environment. You can get particles in a nano powder form, or it can be a colloidal solutions form. And it is one of the easiest method and fastest method. Uh, Fastest method, and comparing to the other method, it is not much longer reacting time. It doesn't take a much reaction time, and it also have a multi steps, and it does not require any toxic chemical for its synthesize. So it is also called as environmental friendly methods or a green method. So next, you may get some question: how to synthesize this nanoparticles by laser ablations? If you want to synthesize silver nanoparticles by laser ablations, you need to have a high purity of silver slice. And if you want to have a copper nanoparticles, you need to have a high purity of copper slice at the bottom of the glass vessels, and it must contain at least 20 ml of H2O, that is water. And if you apply this laser light like 1064 nanometer plus ND YAG laser, and operating of will be at a fixed energy, that is will have a 30 minutes. So this will result in yellow colors, and in case of silver nanoparticles, and if it is in the case of copper nanoparticles, will have a light green color. Then this is the experiment setup of a laser ablations. You can see here. So the laser ablations of nanoparticles by laser ablations is a liquid. It is one of the simplest methods of experiment configurations. So here you can you are going to keep your metal slice. Metal size. If you want a silver metal, you can have a silver nanoparticles. And if you want to make a copper, you will have a copper slicer. In that, when you apply this laser light, it will be vaporized in a materials, and the nanoparticles can be obtained in the colloidal solution form. And here you can use XYZ as a stage to move the target, and you can utilize the complete materials by making a nanoparticles. So this is the process. This process will be a clear idea of how the laser ablations works. You can see that this YAR laser is applied to the metal target. For example, I can give is if you want to make a silver nanoparticles, you will be keeping a silver metal here. And if you want to make a copper nanoparticles, you can have a copper nanometals here. Okay. So when you apply this laser light, it will be vaporize the metals, and this nanoparticles is to be collect an aqueous media. So here you can see in aqueous media. This will be using in XY stage. We can move this target of XYZ in the directions. So here you can see the directions of XYZ positions. So up till this, you may understood that nanoparticles with the physical methods using mechanical milling as well as laser ablations. So now we are going to see nanoparticles by chemical methods. For synthesizing nanoparticles by chemical methods, we need three important components. One is metal salt, and second is capping agents, and the third is reducing agents. So these are some of the example of reducing agents: sodium citrates, sodium borohydrates, and ascorbic acids. And these are some example for capping agents: thiazole, citrates, polymers like polyvinyl chloride, alcohol, PVC, etc. So what happened here is, so this reducing agent will reduce your material salt into metal nanoparticles, but these metal nanoparticles are highly unstable. Okay, it will be highly unstable, so it will try to join together and form a aggregations. So it makes a nanoparticle stable. We have to add a capping agents. Okay, capping agents, or we can have a stabilizing agents that will represent the aggregations or agglomerations. Then we'll have a synthesis of any nanoparticles. This is nucleations and the growth. We'll have a synthesis of any nanoparticles which will be having two steps. One is nucleations, and another is growth. So what is nucleation? You may get a question, what is nucleations? So it is nothing but a phenomena of initiation of formations of fast nanocrystals in the solutions. So it involves in the appearance of small particles and or nuclei. It faces in the capable of growing. Okay, then we'll be having nucleations and growth. For example, for bio, how nucleus is important. Similarly, for nanoparticles, the nuclei is very important. So this is because there are the two types of nucleation. One is homogeneous nucleation, and another thing is heterogeneous nucleation. Homogeneous nuclei is the form of simultaneously uniform throughout the solutions, and the next is heterogeneous nucleations. So it is the nuclides at a different point of radiations. So let us see the picture here. Lammer's diagram, times versus solute concentrations. So once the nuclei is formed, then the growth will be started. So if the nucleation is homogeneous nucleation, that means all the nuclei from the forms simultaneously. You will be getting monodispersion particles. Then monodispersion particle means uniform size particles, and if the nuclei is a heterogeneous nuclei, that means it will be nucleated at a different times. Okay, at different times it will be nucleated. It is also called as polydispersion particles. It means it do not have a uniform size particles. So when you see nanoparticles under transmissions electrons microscope, you will be seeing the uniform size particles, that is called monodispersion particles, and if it is uniform size, that is polymer dispersion nanoparticles. Okay. So this nucleations plays a very important role in controlling the properties of a final product, like size, distribution, as well as naturals of the phases. For making a very small size of nanoparticles, we need a strong nucleations and slow growth. Okay. So we can get a higher uniform size particles if the process is the nuclearization and the growth. We can successfully separate each sizes. So you can see the precipitation here. Yeah. So this is the types of typical precipitations reactions. So here we are going to use the metal salt. Okay. Metal salt and a reducing agent. For these reducing agent, we are going to reduce metal salt into metal atoms. Okay. Metal salt into metal atoms. This metal atoms combines to form the cluster. Okay. This cluster combines to form, see here, this cluster will combines to form primary particles, and these nucleus steps, and this is the growth step of the primary process. And starting from the growing, so we have to stop the growing, otherwise what will happen is all the particles combines and the growth takes very easily and very big size particles, that is the aggregations will take place in the particles, which is not useful. We have and we need a small particles for our applications here. Next is so how can we achieve that by arrested precipitations? So here we have seen only the nucleations by precipitations. How we can have an arrested precipitations method? So what is arrested precipitations? Let us know it clearly. Here a large number of nucleation centers are performed by vigorous mixing. Okay. So when we do a vigorous mixing, the reactions of the solutions, when we have to make a nanoparticles, we have to mix it vigorously. When you mix it vigorously, you will be having more number of nucleations. And here, if you are keeping in the concentrations of growth, keep it small, and the nuclei growth will be stopped. Due to the lack of materials, this is called as arrested precipitations. Okay. And we have to stop the particles by Oswald ripplings. Oswald ripplings. So we need to have to stop this Oswald ripplings. So what is the Oswald ripplings here? So by using the stability, what is ripplings here is the growth of mechanisms where the small particles dissolves and or consumed by the larger particles. What will happen is the results of this average nanoparticle size will get increases with that times. So that particles concentrations get decreases. So if the particle size is increases, it will decrease at the stability. So it is called as Oswald ripplings. And then how will you turn the size of the particles? By turning the size of the particles can be achieved by the controlling the nucleations as well as the growth rate. For example, I can give is faster nucleations will provide higher concentrations of nuclei. And if you yield a small nanoparticles or nanocrystals, but some you will be showing slow or small nucleations, it will provide a low concentrations of seeds. So here you can see the image of nanocrystals, and again the same concentrations of precursors get decreases and increases at the down stage. So the nucleation, if the faster growth, it will give a fast growth, and if it is a slow, it will give a slow refractions. And so that results the larger particles and the simple one. One more example I can give here is consider that we have 5 persons and we have 50 rupees. Each will get 10 rupees. Okay. Each will get 10 rupees as divisions. But when we have 2 persons, each will get 25 rupees as a share. So similarly, this applies to a nanochemistry as well. You need to have, we have a more number of nuclei, and the precursor is the amount of same. So that what happen in this is you will get a small size particles. And doing a small nucleations, you will be having a only 2 nucleus that is again will be the precursor in the same everything will be same in the unit, and it consumes a crystallizations, and this size will bring it in the bigger size. Okay. So there are some roles and importance stabilization agent which will be using in the useful in the stabilizing process. So what are the roles of stabilizing agent? So here it is to be preventing in uncontrollable growth of particles, and it will prevent a particles aggregations, and it will control the growth rate, and it also controls the particle size, and it will also be allow the particles to solubles in various solvent as well. Okay. Next is the stability of nanocrystals against aggregations. So here we have 2 process. One is electrostatic stabilization and steric stabilizations. So here what happens is the repulsion, the stabilization agent will get the repulsions in the observations of ion surface, where it creates an electric double layer, which results in the Coulombic repulsions between the individual particles. So likewise, here the steric stabilizations will show the metallic center by a repulsions. Here it will be taking repulsions. Here it will be taking attractions in a bulky products. For example, they have given polymers and surfactants, etc. So the metallic nanoparticles synthesizer. So what will happen here is one, if the metal is taking place with the reactant, it will give a nanoparticles. Likewise, if a metal is taking place in a nucleus, it will give a metallic products. Okay. Here in metal, it can be platinum, copper, cobalt, ion, etc., etc. Here reactant should be citric acids, next alcohol, as they have given here, citrates, bromohydrates, etc., etc. You can use any types of reducing agents. So next is a synthesis of a gold nanorods. So this is also a main process of chemical methods. So here the formations of mechanisms, where it will have either seed formations or a nanorod growth. So here you can see it is a seed formations or it is a nanorod growth. So the NaBH4 is a strong reducing agents, and citrate is the capping agents here. And ascorbic acid here is a weak reducing agents, and CTAP is a rod-like templates. So this first the seed formations will take place in the second step as well. That is seed mediation growth for gold, or as well as you can take it in a silver product as well. So these are the gold nanorods, and there have some 2 related factors for the growth. One is seed size, and the other is length of the trials. length of the cells, as we have seen here, CTAB. So here it will be main thing for the nanorod growths. So up till this is types of types and the importance of nanochemistry. So if you have any doubt, you can question me. You can also contact my sites if you have any doubts. Thank you for giving me this opportunity for YK Talents and everyone who is present here. Thank you, everyone.
Thank you for your great presentation and performance.
Thank you, ma'am.
Thank you.